let me show you what a mass spectrum looks like nowadays. Traditionally, Cornell is a great center of mass spectrometry, but the best picture I could find was at Wisconsin. So the machine is in green. And the key relation is deflection, which is what's measured in this machine, is proportional to the charge times the velocity of the particle times the magnetic field over m. The two variables being the charge and the mass. And the actual data from these machines looks like this. It reports the mass to charge ratio, so it's traditional not to report the charge to mass ratio, the mass to charge ratio. And big peaks mean you've got a lot at that mass to charge ratio. So very useful tool. Okay. The main part of this clip is about Dalton's laws, because you may not have noticed this, but Dalton's laws aren't doing very well right now. Here are the laws that we had. Matter is composed of indivisible atoms. All atoms belong to an element. All atoms of a given element react the same and have the same mass. Molecules have fixed ratios of given elements, and reactions neither create nor destroy atoms. Which two of these statements have we in the last lecture and today shown not to be true? Put it in chat. Which two of these statements is not true? Put it in chat. Good. Matter is not composed of indivisible atoms. Atoms can be divided into electrons, protons, and neutrons, and nuclei. Each element has different isotopes. So not all atoms of a given element are the same. So that's two of Dalton's atomic theory that are not true. And there's one more, which physicists demonstrated was not true. This fifth statement, reactions neither create nor destroy atoms. We now know that statement is false. So, the key is that physicists discovered radioactive decay. Nuclei can emit alpha particles. And alpha particles consist of 2 protons and 2 neutrons. So uranium can emit an alpha particle, uranium-235. It loses 2 protons to go to 90 protons from 92. It loses 2 neutrons, so its atomic mass goes from 235 to 231. That clearly breaks Dalton's fifth rule. There's another kind of radioactive decay that changes the element. It is beta decay. Either look at neptunium to plutonium. The mass has not changed, 239 to 239. Look at that data, neptunium Np to plutonium. Has a neutron turned into a proton, or has a proton turned into a neutron? Put it in chat. The key is the 93 protons in neptunium and the 94 protons in plutonium. So plutonium has gained a proton without changing its mass. A neutron turned into a proton. That's a beta minus decay, loss of an electron actually. Last example, beta plus decay. And notice that magnesium and sodium, these two are both with the same atomic mass. In this last example, look at it carefully, look at the number of protons, and decide whether a proton has turned into a neutron or a neutron into a proton. In chat, please. Good. So 12 protons has turned into 11 protons without a change in mass. Therefore, this is, in this case, 1 proton turned into a neutron. An important concept is that of half-life. Half-life, which is called T1 half, is how long it takes for half of an element to affect one of these transitions. So uranium-235, it takes forever. It takes 23 million years for half of uranium-235 to turn into thorium-231. but half-lives can be much shorter. The neptunium to plutonium reaction, half of it turns in 2.4 days, and the magnesium into the sodium in just 11 seconds. So those are examples of reactions changing the element, and there goes the fifth of Dalton's rules.